Good morning, students. Our today's topic of discussion on Explain Why is aortic aneurysms are more prone to rupture. What is aneurysm? Any kind of aneurysm means dilatation of part of a vessel due to weakness in its walls. You can see here on the left hand side it is a healthy abdominal aorta, and on the right hand side you can see the abdominal aorta with aneurysm. It is unusually dilated. Now aneurysms are unstable and they are very prone to rupture. This can be explained by Bernoulli's principle. The relationship E or total energy is equal to P plus half rho V square plus rho GH. This is known as the Bernoulli's principle. It means that the total energy flow or E at any given point of the moving blood is constant. In this equation, P is the lateral pressure or the pressure energy or the static pressure energy. Half rho V square is the kinetic energy per unit volume, where rho is the density and V is the velocity of the blood, and rho GH is the potential energy per unit volume. This relationship means what? At any given point, suppose half rho V square or the velocity of blood is increased, that means this half rho V square or kinetic energy component will be increased. In order to keep this E constant, there must be simultaneous decrease in the lateral pressure and vice versa. This can be well explained by this picture or graph. Here we can see that at the middle portion the tube is narrowed because the surface area, total cross-sectional area is reduced in this area. This means at the central part of this tube the velocity of blood will be increased. That means the half rho V square or the kinetic energy component is increased. In order to keep the total pressure constant, the lateral pressure of the wall must be reduced. And the same thing we can see here. Here you can see that the pressure it is reduced, the lateral pressure is reduced in the area where the tube has become narrow. The opposite thing that happens in the dilated part of the aneurysm. Here the aorta or the blood vessel, it is not narrowed, instead it is dilated. So the cross-sectional area is increased, hence the velocity increases. If the velocity is less, that means the kinetic energy component of this Bernoulli equation, it is reduced. In order to keep the total energy constant, the lateral pressure must be increased. So in the aneurysm wall of the aneurysm, the lateral pressure of the blood it is increased. Already the wall is dilated and weak, and with this increased lateral pressure, there will be further stretching of the wall of the aneurysm, and as a result, the aneurysm will become unstable and prone to rupture. This explains why aneurysms are more prone to rupture. Thank you and subscribe.